Let us come to inequality in a triangle. Now let us understand how the sides of a triangle are related to each other. Okay, it says that the sum of any two sides of a triangle is always greater than the third side. Always remember, the sum of any two sides of a triangle is always greater than the third side. Now to prove that, we'll take an example. Okay, now what we'll do is we'll draw a right angle triangle. Okay, now let's take the base as 4 centimeter. Let's take the height as 3 centimeter, and we know that the hypotenuse is actually the side which is opposite to the 90-degree angle, and we'll come to know that the hypotenuse here will be 5 centimeter. Okay, you can even draw and find out, or if you come to Pythagorean triplet, you will find that if the base and the height is given as 3 and 4, the hypotenuse will be equal to 5 centimeter. Okay, so here we can find out, we can actually analyze as to the sum of any two sides of a triangle is actually greater than the third side. So here what we'll do is we'll first take 3 centimeter and 4 centimeter. Now if we add it, that gives us 7 centimeter. It is greater than 5 centimeter. If we add 5 and 4, that gives us 9, which is always greater than 3. So therefore we conclude that the sum of any two sides of a triangle is always greater than the third side. Okay, now let us come to equality in a triangle. So I've written that if two sides of a triangle is equal, then the angles opposite to it will also be equal. Now let us see. We have this isosceles triangle where the two sides are equal. Now remember that, suppose let us mark it as ABC. Now this angle C here is actually opposite to side AB, and this angle B here is actually opposite to side AC. I repeat, angle C here is opposite to side AB, and angle B here is opposite to side AC. And since AB is given equal to AC, I repeat, side AB is given equal to side AC, therefore angle B will also be equal to angle C. Okay, so this is what the property says, that in a triangle, if two sides of the triangle are equal, then the angles opposite to it will also be equal. Okay. Now let us come to Pythagoras theorem. Okay, Now Pythagoras theorem is actually a theorem given by a Greek mathematician, Pythagoras. Okay, so Pythagoras theorem is actually based on a right angled triangle. Okay, this is a right angled triangle where this is called as the base, this is called as perpendicular, and this is called as the hypotenuse. Okay, so Pythagoras said that there is a relationship between the base, perpendicular and hypotenuse of a right angle triangle. Okay, and he said that the square of the hypotenuse is actually equal to the sum of the squares of its base and its perpendicular. I repeat, he said that in a right angle triangle the square of the hypotenuse is actually equal to the sum of its base and its perpendicular. Okay, now let us write it down. Okay, now what I have written is, I have written in a right angle triangle the square of the hypotenuse is equal to the sum of the square of its base and the square of its perpendicular. Okay, so in a right angle triangle we have this as the hypotenuse, this is the base and perpendicular. Now let us see how the square of the hypotenuse is actually equal to the sum of the square of its base and the square of its perpendicular. Okay, let us take this as 4 centimeter and this as 3 centimeter. Okay, naturally this will be 5 centimeter. You can draw a right angle triangle and you will find that if you take the base as 4 centimeter and if you draw a 90 degree and take this as 3 centimeter, this line will be measuring 5 centimeter. You can check on that. Now let us draw squares. Okay, now from 4 centimeter we can draw a square here. This is all 4 centimeter here. Similarly with 3 centimeter we will draw a square here. This is all 3 centimeter here. And with 5 centimeter we will also draw a square. Okay, now the value of the square here is 3 into 3, which is equal to 9 centimeter square. Okay, the value of this square here is 4 centimeter, 4 into 4, that is equal to 16 centimeter square. Okay, now the value of this square here is 5 into 5 is equal to 25 centimeter square. Now you can check here that the sum of 9 and 16 is actually equal to 25. Okay, so we can prove that. Okay, we can prove that in a right angle triangle the square of the hypotenuse is actually equal to the sum of the square of its base and the square of its perpendicular. So this is what was given by Pythagoras in his theorem. Okay, now in the other way also we can see, or vice versa we can see, that in a triangle, if the square of the hypotenuse is actually equal to the sum of its sum of the square of its base and the square of its perpendicular, then take it for granted that it is a right angled triangle. Is that clear? So in a right angled triangle, when the square of the hypotenuse is equal to the sum of the square of its base and the square of its perpendicular, so we can check the other way also. If in a triangle the square of its hypotenuse is actually equal to the square of its is actually equal to the sum of the square of its base and the square of perpendicular, then it should be considered as a right angled triangle. Okay, so that is all on triangles and the properties. I hope you have understood and do the problems accordingly. Thank you.